Okay, all right. So what we're gonna do today is this. We are going to spend the day graphing exponential functions because I don't know if you realize we're like 10 days in. We actually never graphed it yet. All right. And there's a reason for that. Because the back end of this unit is nothing but graphing. Okay. And try to move the graph around also. Okay. So that's called transformation. So, but let's take baby steps first. Let's talk about how to actually graph it by hand, and then looking at it from a calculator. Okay, all right, let's go. Okay, all right. So here's what we're gonna do today. Let's graph some exponential function. Now I want to show it to you by hand because um, with using when you do it by hand, should they ask you to graph something like an exponential function from scratch, then you could be able to do it. Okay, so I just wanted to show you this. All right, so okay, so here we have a table of values all set up already, right? And so what we're gonna do is this: we're gonna take a look at this function, and here we got the table of values, right? And this is the function, right? Because this is really just f of x equals to 3 to the x power, right? Again, remember, let me just make sure I'm recording. Okay, all right. So here, right? So they did one example already for us. If x is negative 3, right? As you can see, if x is negative 3, 3 to the negative third power. By the way, you understand why the first lesson of this unit was on all the rules for exponential powers, right? So, okay, all right. Now, here's 1 over, right? So if you got 3 to the negative third power, put a 1 over it, right? And then that becomes positive, right? And so the exponent becomes positive. So 1 over 3 to the third, 3 to the third power is 27. So the y value is 1 over 27. What's the coordinate? Yep. The ordered pair is 3, negative 3 comma 1 over 27. Right? So we're just going to do some of these together. Okay? So here is 3 to the negative second power. All right? It's up to you whether you want a parentheses or not. So this is 3 squared. And that would be 1 over 9. Right? Negative 2, 1, 9. Now, graphing it is going to be kind of tough by hand on a graph, but uh, I'm going to show you how to do it. All right, so 3 to the negative first power, which is 1 over 3 to the first power, which is 1/3. Right? See, super fast, right? That's a little bit more graphable, but the next one is where this really all starts. Now, this is 3 to the 0 power. What's 3 to the 0 power? Yeah, 1, right? So this 1, so there we go, 0, 1, all right? And that would also be our y-intercept, right? Okay, all right, y, and then 3 to the first power is 3, so it's 1, 3. So the graphing here becomes much more easy without the negative exponents, certainly. So that's 9, 2 comma 9, and then lastly to the third power. This third one is going to be a little bit tougher because it's 27, right? 3 times 3 times 3. So this is 327, like that. Now, let's do try to graph it, okay, without even looking at a graphing calculator. So the easiest points to graph are these three, of course, right? Because I don't have 27 all the way up there, but let's give it a try. So 0, 1's right here, and then 2, 1, 3, 1, 3. All right, and then 327. No, 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 2, 9. Now I will say this though, all right, because this just flashed across my mind. With this graphing, a lot of times they actually give you the interval. So meaning like where x is between 0, oops, shouldn't have done it like that. It's between 0 and 2. They might say something like that, meaning you only have to graph this. Sometimes they do that, okay? And then your graph will look like this. Right, I'm gonna try to do my best. All right, it's a curvy graph that goes through like this. All right, but in this case, it's not. So we're just gonna do our absolute best. All right, to get the closest thing possible. Negative 1, 1/3. So it's like right 1/3. This is a half, so this is about a third. So there's another point for us. So that kind of helps a little bit. I'm trying to do the best job I can here. All right, so look something like that. Actually, it's not bad. Actually, I gotta tell you. And then this one's just gonna keep going anyways, right? And then here now, this one is tricky because these numbers, this group of numbers here, as small as they are, they would never really get to zero. So don't plot a point right on zero where y is, because that's not true. So, and again, I know it's tough. So let's kind of go like that. Okay, that's really not ideal. All right, like something like that with an arrow. Okay, and that's the best you can do. Now we're gonna label our graph because all the cool kids do it. 3 to the x power, just like that. Okay, that's it. That's the best you can do. Okay, now that said, let's look at what it looks like on a graphing calculator. All right, so let's go to the calculator. Let me just make sure I'm still recording. All right, let's see. All right, where's the calculator? Okay, let's go to y equals, what's the equation? 1/3 x. Yeah, okay, all right. I'll put in parentheses, okay, just to be safe. 1/3 to the x power. Okay, so now let's take a look at the graph first. Wait, what? Wait, what? Did I do something wrong? Hold on. Hold on, let me press pause. Oh, I get it. Okay, all right, I get it. So it's the first one is 3x. The next one is 1/3 x. That's why I used a different. There's a different number. That's why I was like, why does the graph look like that? So yeah, the graph is right. It's 1/3 x. Okay. So now, how do you graph that, right? Good question. If you have to do this on the test, look at the table of values. Now, if I were you, I would pick the quote unquote nice numbers, meaning you want whole numbers. Like you don't want to deal with this, right? 2 comma 0.11 repeating, so on and so forth, right? Because look, I mean, these are all the exponential. It gets exponentially small, right? So you don't want to mess with that. So again, let's focus on what we can. -2, 9, right? That's totally manageable. So let's see. Let's use blue, all right? -2, 9. Where's 9? -2, 9. What's the other point? -1, 3. And then what is that? 0, 1. Alright. And then I'll try to connect them. I'll use a thinner line. I might have a hard time because this is on the left hand side. Alright, go slow and steady. There you go. Alright. And then I'll just keep like going. Now let me get 1 point. 0, 1, and 1, and then a third. 1, and then a third. It's actually down here. Okay, alright, let me erase that a little bit. Alright, let's see. Like this. It's more like this. Alright, and then the line just sort of keep going. Don't let it touch 0. Don't let it touch the x-axis. Okay? Alright, so that's y equals, or f of x is 1/3 to the x power. That's it, okay? That's how you do it. So, again, let me summarize on how to graph this. Pick nice points, alright? Pick whole numbers, alright? -2, 9, -1, 3, and 0, 1. Okay, now how are we doing on time? Oh, not bad. Alright, let's practice a little bit, and then I don't want to spend more than a day on this. Alright, so, Regents questions, okay?
A few moments later.
Okay, alright, so as I'm doing this right now, I'm actually really mad because I recorded this earlier, this particular part, but when I saved it, this part got cut off, even though this is like a really important part. So I'm kind of mad right now as I'm doing this because I did it in the morning and now I gotta like finish it in the afternoon. All right, anyways, so look, uh, like I said earlier, the oh wait, hold on, let me move the mic. Like I said earlier, I gotta make sure I'm recording. All right. Like I said earlier, the this question is what I was saying earlier, right? You see how they gave you an interval because they didn't want to torture you by making you graph decimals, right? So like what I said here, right? Here, you got an interval that you got to graph, right? Which makes plotting the actual points easier, the nice points, right? Quote, quote unquote. So we're gonna do this, all right? Now let me go get the calculator. Now, when you're doing this question, what you should do is this. You should still write out the table of values, only because it's also for your benefit, all right? So what I'm gonna do is this. Let me write this down. So here I got this, right? I'm gonna set up a table of values. X to this x power y and then xy. And what I'm going to do is I'm going to enter in that equation. Y equals 2 to the x power. All right. Again, the power in the x, right? X in the power, I mean, is what makes this a exponential function. So let's graph that. There's our graph. Okay. So let me look at the points. So, okay. Now, they want -1 to 3. So in my table, I'm going to set up like this. -1, 0, 1, 2, 3. So we got our 5 points, right? 2 to the -1 power is a half, right? You could do this by hand, by the way, okay? You don't have to, like, you know, do this using a calculator. So 2 to the 0 power is 1. So we got 0, 1. 2 to the first power is 2. So we got 1, 2. 2 to the second power is 4. So we got 2, 4. All right, pardon the handwriting, because I don't like doing the same thing twice. It drives me mad. So 3, 8, right? So the table will show you that too. Like, so if it says the interval is from -1 to 2, right? -1, 0, 1, 2. Wait, did it say that? To 3, right? So 3 is 8, so on and so forth, right? So let me plot those points, okay? So -1.5, that's right here. All right, and then 0, 1, 1, 2, 2, 4, 1, 2, 3, 4, and 3, 8, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, I'm going to connect them. Now, here's the thing, right? Connect just these points that you plotted. These 5 points, right? 1, 2, 3, 4, 5. All right, hold on. Let me calm down and then draw the lines. Okay, this is really not good because I'm really mad right now. I'm really mad. I can't believe it got cut off. Like, now I got to do 10 minutes worth more videos. All right. All right, this is a little better. All right. Now, I think many of you might be thinking, hey, do I need to put arrows in there? And the answer is no. And I can tell you that in the affirmative because I checked the answer key. Okay. So you don't need the arrows here because the interval's been defined already. Now, what I will say is for you to write the equation here to name the line. Okay, that's it. All right. Justify your answer. Will this graph ever intersect the x-axis? Meaning, would it ever like touch the x-axis? Meaning, would y ever be 0? Right? Because you have to go all the way down there. So let me show you then. All right. So look, would it? No, because it gets small and small, right? Notice how these decimals get smaller and smaller. Now, you might say, Mr. Ring, hey, look here, Mr. Ring. I got, you know, -5 here. That means it crossed the x-axis. Not true. This is scientific notation used by the calculator. What it's saying is take this number, take the 3.05, whatever, right, and move the decimal place 5 times to the left. So you would move it 5 times to the left like that. So it's a super tiny number. That's very close to 0, but it never quite crosses it. So what's the answer? No, it doesn't. All right? It doesn't do that. It doesn't intersect the x-axis. Justify the answer. You can say that the number approaches 0, but it would never reach it. Something like that. Okay? Now, 8 is something that we've done already, actually. It was the first example, except with the interval defined. So we don't need to do that. All right? Now, next question. This one takes a long time. For this one, we're going to graph this. So let me put this in the calculator first, which is what? 2 to the x minus 7. Okay, all right. So let's go to y equals, clear, 2 to the x power. Now, to get out of this superscript, this little arrow here, just press right, like that. Okay, see that? All right, if we go left again, right, go right like that, -7. What does that mean? Now we just need to graph it. So here we got a graph, and then I got my table of values. Now, does it say anything? No, they just want you to graph it. So again, let's find the nice points. So let me go to negative. Yeah, look at these numbers. -11, -7. Let me plot that. Okay. Negative. So actually, I remember now. The original video, I didn't do this. -11, -7. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. All right. So let's do this. So let's see. -1, 6.5. You know, I'm just gonna go with this. 0, -6, 0, 1, 2, 3, 4, 5, 6, so on and so forth. Okay. 1, -5, 1, -5, 2, -3, 2, 1, 2, 3, 3, 1, 1, 2, 3, 1, 4, 9, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? And then you connect them. All right. Now, it says that it ends at around -7, right? So, so you just connect them, all right? And then that's it. And then name the line. Don't forget that, all right? Now, what does the next part say? Okay, all right. So this one is interesting because they just want you to compare two functions. So here we got f of x and we got g of x. And they want you to evaluate both. Okay, the computer is very glitchy right now, which makes me even more mad. All right, what was the original equation? 2 to the x minus 7. And this one is, now this is not, by the way, the g of x, that's not an exponential function because the x is not in the exponent. It's a linear function, okay? I just want to check that with you. Now, 2 to the x minus 7 when it's a function, oh man, what's going on? All right, f of 4, right? Now, I don't need to calculate because I can just look. Oh, wait, is this still the same equation? Yeah. All right, let's see. Let's look at it. Right? It's 9. Now, I can double check. So 2 to the 4th power, right? 2 times 2 times 2 times 2. 2 2 is 4, 8, 16. 16 minus 7. Yeah, 9, right? And then let's evaluate this. When g of 4, which means 1.5 times 4, that's 6. 6 minus 3 is 3. So the question is 9, right? Is f of x when x equals 4, which is 9, greater than g of x when x is 4, right? The answer is 3. Yes, right? Because 9 is greater than 3. That's it. Okay? All right. Not bad, actually. Let me stop. Oh my gosh, 10 minutes. Oh, wow. Okay, all right. Let me stop now. Thanks for watching this, and I'll see you tomorrow. Okay. All right. Bye-bye.
OMG, that was so good.